Alright, this is Computer Science 305, Programming Languages, and today we're talking about our third look at ML. And so, if we recall from ML2, we were looking at pattern matching, and we talked about defining local variables, and then later we looked at a sorting example. Well, today we're going to explore a little bit more about pattern matching. We're going to talk about function values and anonymous functions, higher order functions and currying, and then finally we'll get into predefined higher order functions, so actual things that are there for us. So we'll take a look at more advanced pattern matching. So today we're going to work, I'm going to start with just creating a file. We'll call this ML3, we'll say this ex01.sml. And so first off, last time we're not going to get too deep into some of these things, but one of the first things we saw was, like, for example, function f0. And actually, what I'm going to do is I'll open up a terminal so we can execute a couple of these things straight up without having to worry about it too much. So if we're in SML, and we saw that we created function f0, right, equals 0. And then we had f, sorry, I need a pipe. F and then 1, underscore was equal to non-zero. And then that gave us, this nice function that mapped it into a string, right? And we could call this, we say f -1 was non-zero, f of 0 was 0, etc. Well, that's great. But interestingly enough, pattern matching occurs outside of functions as well as outside of variable declarations. We can also use it when we want to define cases, right? So we can actually have a case n of something, which I don't know if we can actually do that in here, but let's say we have function fn equals, and then we can define a case n of, and then we say 0, 0, or underscore non-zero, right? So we look at that, and that defines this, and we can run it the same way: f -1 and f0 or f1, right? Boundary cases, and we get everything we expected. So match syntax, right? Basically is saying we have some rule. A rule is a piece of ML syntax that looks like this, right? We have a pattern with the rocket operator followed by an expression. So a match consists of one or more rules separated by a vertical bar, like this. So we have some match. You have a rule followed by, or you have just a single rule, or you have a rule followed by a vertical bar followed by a match. So each rule in a match must have the same type of expression on the right-hand side. Excuse me. And a match is not an expression by itself, but forms a part of several kinds of ML expressions, right? So in this case, our matches, our rule was 0 or any value, right? The underscore. Our matches were the string 0 or the string non-zero. Does that make sense? Right? Sorry. Well, let's rephrase that. Our rules were 0, the pattern 0, followed by the expression, the string 0, and then the second one was the underscore followed by the non-zero as the expression, right? All right. So, so what we just looked at was called a case expression, right? We can write that by itself. For example, we say case 1 plus 1 of, right, and then we say 3. So these are our rules, right? And then we have basically 3, or we'll do or up there, 2, or 2, or, and then if we have, for anything else, we're just going to say and that's HMM, and then it returned 2, right? As expected, right? So the syntax for a case expression basically is just the keyword case followed by some expression, and then the keyword of followed by a match, right? And as we saw before, match can be defined as above. A match is defined by a rule, at least one rule, or a multiple rules with alternation bars, where each rule is defined as a pattern followed by with a rocket operator followed by an expression. So using that, we can also get a little bit more interesting, right? So this is a very powerful case construct. Unlike many languages, it does more than just compare with constants, right? For example, we saw more capabilities than comparing with constants when we looked at Ruby, right? The Ruby case when statements are far more powerful than, for example, the Java switch statement or the C switch statement or the C++ switch statement, which are weak and only look at constants. We can do so much more in both ML and Ruby with the case statements built in, right? In the case of, for example, ML here, we can actually do all sorts of pattern matching that is really amazing. And so in the case of the one shown here, we have some case where we have x of, and then what we have is, we're trying to match, is this, so is it a list with at least four items? We're going to match the third item, and that's what we're going to return. Or is it a something cons with B, cons with something, which is in this case, a list of 3 items. And then if it is, then we'll return the second item. And then on the other hand, is it A cons with something, then we'll return A, right? Oh my god. Well, that's going to fail, but anyway. Not quite what I want, but, and then if it's nil, we'll just return 0. In this case, we don't know what x is, so it's going to give us a failure, but we can see, so if I define, let's say, var x 0, let's say 1, let's say 1 cons with 2, cons with 3, cons with nil, sorry, val x equals 1 cons with 2, cons with 3, cons with nil. Apologize, I know too many languages that know var and val as the constructs to create a variable. So we create the list right now. If we rewrite that case x of, and we say underscore cons with underscore, cons with c, cons with underscore, right? We'll return c, or we say underscore cons with b, underscore cons with underscore, we'll return b, or underscore cons with, a cons with underscore returns a, or if it's nil, we will return 0. And so that gives us 3, right? Because if we take a look, it was 1, 2, 3, but it was actually 1, 2, 3 cons with nil, which matches the first case, and we return C. So it works out great. So the value of the expression is the third element of the list x. It has at least 3, or the second element if x has only 2, or the first element if x has only 1, or 0 if x is empty, right? Because we're always, all lists are cons with nil at the end. So 3 items is actually 4, so meaning the first one. 2 items is actually 3, meets the second case. A list with 1 item is actually 1 with 2 if you cons with nil, and that meets the third case. And otherwise, if it's empty, it's just nil, right? Because it's nothing cons with nil, and that gives us the last case. Okay. So moving a little bit forward, we can also generalize if, right? So initially, well, that's what the case statement does. It generalizes the if. If is very limited, right? So it says if the expression, then the expression, else the expression. Well, that's very weak, right? It does not give us all possibilities. The case statement says we can case on the expression 1, and then if that's true, we execute expression 2. Otherwise, right, we can execute expression 3. The 2 expressions above are equivalent, so if then else is really just a special case of case, but case also allows us to do far more than what if can generally do. Okay, so we've that gives us the capability to do deeper pattern matching. In the next upcoming video, what we'll do is we'll look at function values and anonymous functions, and so we'll get to that in shortly.